Hello class, today I'm going to solve and record the example question when we have a manometer with several different types of fluid inside, and hopefully this practice is going to help us to understand better and finding pressure. For this question, the question says we have a gasoline line is connected to the pressure gauge through a double U-tube manometer. And the pressure at the air side, this is the gauge, is 370 kilopascal, and says find what is the pressure on the gasoline end, which is the purple color. So the air pressure is given, we need to find pressure at the gasoline end. To do this, we need to write down the pressure balance for this apparatus, and then we can find unknown pressure. Okay, so let's start from left side, which is going to be air. If you remember from the lecture, we talked about that for small height differences for the air, we're not going to consider any pressure change. As you can see, for the gauge and the pipe for the air, it's just 45 centimeters. So nothing big is going to change for the air. So for different points, for example, here, all they're going to have same pressure. So starting point for us going to be this point. So I'm going to call this point point 1. So let's write the equation. That point 1, which is connected to the air, is going to have pressure of the air, and they call that P gauge. So P gauge. For the air, I'm using black color. So now I'm at point 1. Same height, same liquid. We talked about this. I need to jump from left side to right side. So now I'm here, point 2. Okay, so from point 2, I'm going to move upward to decrease pressure. Upward till I have water. So I can go up to this point, point 3. So let's write down that pressure for the water. I'm using blue color. It is upward, so minus gamma for water, and the height for that from point 2 to point 3, which is 45 centimeter. For now, I'm writing H for water, but we know that I mean 45 centimeter height. Okay, now I'm at point 3. Same height, same liquid. Again, it's time to jump from left side to right side. So now I'm at point 4. From point 4, I should go downward up to this point, which is going to be point 5, which we have oil, the orange color. Because it is downward, I'm going to add this pressure. So plus gamma for oil times the height. What is the height? That 50 centimeter. So for now I want to write just based on the parameters. So I'm calling that 50 centimeter height of oil. Great. From point 5, again we have the jumping situation, because same height, same liquid. As we talked, I'm going to jump to this point, which I'm going to call point 6. So from point 6, I need to go upward till the next fluid. So it is going to be this point. So 0.7 is going to be very close. It is upward. Again, I need to subtract. What is the fluid? It's mercury, and the color is gray. So let's use gray. Upward minus, it is mercury, so gamma for Hg and height is going to be that 10 centimeter. So for now, H for Hg. Great. From 0.7, we have another fluid, which is gasoline. From 0.7 up to this point, which is going to be 8, and it is upward. So again, I'm going to subtract. The color is purple, so purple minus gamma for GS for gasoline, and height, which height? That 22 centimeter there. So H for GS gasoline, and I'm looking for pressure here for gasoline here, 0.8 and for the pressure of the gasoline inside the pipe would be same. So this is going to be equal P for gasoline. Great. Now we did the hard part, and we have all the pressures and the pressure balance for this arrangement. Okay, so let's rearrange. So we are looking for this item. Let's rearrange in terms of that. So P for gasoline is going to be equal P for gauge minus, as you can see, instead of giving us specific weight or the gravity or the density of the different liquid, they gave us a specific gravity. So you need to multiply with the density of the water. Okay, so let me remind you, a specific gravity was density over density of the water at 4 degrees, or gamma over gamma of the water. We just multiply with G. Okay, so let's use our formula. So because for the oil we have Sg and for mercury we have Sg, I'm going to use like this. Let's write. For the water is going to be density of the water times G, which is going to be gamma of the water, times HW. And for the for the oil, it is going to be orange, so plus it is going to be Sg for the oil times rho of W and G, which is for the water. I'm basically using this part, times the height of the oil. Okay, so this portion is for this. Okay, let's go for the mercury, which is going to be gray, minus, again, where's mercury? Here, Sg is given, so it is going to be Sg for mercury times density of the water and gravity times height of mercury. Now we reach to the gasoline minus, what about gasoline? Again, Sg is given, Sg for gasoline times gamma for water times G times the height of gasoline, which we're talking about that 22 centimeter. Great. As you may see, we have repeated density of the water and gravity here, here, and here. So I can factor out and simplify this equation. So I'm going to use just one color for now. So pressure of the gauge minus rho for the water times G, because I have a negative, it is going to be HW. This positive is going to be negative because of the negative outside. It's going to be Sg for oil times height of oil. This negative is going to be positive, Sg for mercury, height of mercury. This negative is going to be positive, Sg for gasoline, height of gasoline. Great. Now I just simplify it, nothing special. Okay, let's put the values. So the gauge pressure is 370, but the unit is kilopascal. I could do better here. Kilopascal. So for the others, I can convert this to Pascal by multiplying 10 power 3, or convert all the others to kilopascal. It's your choice. Let's select, for example, in terms of kilopascal. So minus, let's consider density of the water 1000. Gravity is 9.81 times the height for the water is 45 centimeter, so it is going to be 0.45 minus Sg is, what is the Sg for the oil? 0.79, so 0.79 times the height of the oil, which is 50 centimeter, so times 0.5, so half a meter, plus for the mercury, Sg is 13.6 times the height. What is the height? It is 10 centimeters, so it is going to be 0.1, and finally plus Sg for the gasoline, it's 0.7 times the height, which is 22 centimeter, 0.22 centimeter, and these are Pascal. So but I know that 1 kilopascal is 1000 Pascal. So basically I converted this part to kilopascal. Great. So we can calculate this with the calculator, and the gauge and the pressure for the gasoline is going to be 354.6 kilopascal. Okay, thank you very much for your attention.